Hey guys, good evening, and welcome back again to your Unacademy NEET English channel. I hope all of you doing great. So, my dear students, can you quickly let me know in the chats if I'm perfectly audible and visible to every one of you? Can you quickly let me know in the chats if every single thing is perfect? If I'm perfectly audible, visible to everyone? Just let me know quickly in the chats, people. Everyone. Just let me know quickly in the chats if all of you can hear me. If I'm perfectly audible, visible to every one of you. I want to know quickly in the chats. I want to know quickly in the chats, people. All right. So, my dear students, so this is going to be our first session. This is going to be our first session of the NEET 2027 preparation when it comes to the Phoenix 2.0 batch, right? As you know, the first class we always take on YouTube itself. So that's why today's session is on YouTube. Perfect. Well, all the other sessions will be taking on the Unacademy app, right? All the other sessions will be taking on Unacademy app. So first of all, can you let me know in the chats? Has every one of you enrolled in the Phoenix batch? Say yes or no quickly in the chats. Can you let me know in the chats, people? Has everyone enrolled in the Phoenix batch quickly? Yes or no in the chats, quick, everyone. Everyone in the chats. Has everyone enrolled in the batch? All right, I can see everyone has already enrolled in the Phoenix 2.0 batch. That's amazing. That's great. So, my dear students, today we are going to kickstart our preparation when it comes to the NEET 2027. Okay. First of all, few things before starting the session. Few things I'm going to address here. Few things I'm going to tell you here. My dear students, you are going to follow the batch on regular basis. Okay. Do not create any sort of backlogs. Just watch every single session live in the batch. Okay? Just keep this particular thing. Just remain disciplined. That's what we want from all of you. Okay? Just we want that's something we want from all of you. We do not want anything else, my dear students. It is just you have to remain disciplined. You have to follow all the lectures on a regular basis. Rest everything. You will see in the batch the kind of the content which we are going to provide. Okay, that is going to be definitely the level up content. Okay, that's definitely going to be the level up content. Every single thing, be it the DPPs, be it the study material, be it the lectures, every single thing will be level up, my dear students. Okay, it'll be similar to JEE mains. It'll be similar to JEE mains. All right. Okay. So today we are scheduled only one class, that's my class, and from tomorrow you are going to have all the classes. From tomorrow you are going to have all the classes. Okay? Today we had only one class, that is my class, that is the today's session which you are watching right now. From tomorrow you guys are going to have all the classes on a regular basis. Okay? And guys, in this particular batch, we'll be starting with the class 11th chemistry itself. Okay. Your entire syllabus will be completing by December end or maximum by 15th of January. Okay. Your entire syllabus of physics, chemistry, biology will be completed by December end or maximum by 15th of January. We have kept the buffer of 15 days. Okay. So you need not worry about the syllabus completion. Every single thing is already planned. As I told you, it is just you have to follow the sessions on regular basis. That's all we want. That's all we want. Okay, and today it is the first session. Therefore, first session we take on YouTube, and from tomorrow, all the other sessions will happen in the app itself. Perfect? And guys, since we are going to start with physical chemistry, right? We are going to start with physical chemistry. My dear students, I would want you guys to buy one book in physical chemistry. I would want you guys to buy one book in physical chemistry. And what is that book? Apart from the material which we have, apart from the study material which we are going to provide you, I would still want you guys to buy one book. And that book is N Avasthi. Okay? That book is N Avasthi. It will be 200-300 rupees cost. Okay? I would want you guys to buy that book for the NEET. All right? Am I clear? Am I clear, guys? Apart from the study material which we are going to provide you, right? You know, if you are the iconic subscriber, then this study material which will be provided to you. Perfect. But my dear students, still, I would want you guys to buy one book in physical chemistry. That is going to be N Avasthi for NEET. All right. So today there was only one class scheduled. I had deliberately scheduled only one class today in the batch. From tomorrow, you are going to have all the classes. From tomorrow, you are going to have all the classes, guys. So again, people, again, let me tell you, the ones who did not hear me, I would want every one of you to buy this particular book. Apart from the study material which we are going to provide you in the batch, apart from that, this is something extra. Okay, this is something extra which I would want you guys to solve. Okay? Perfect. So, should we start? Is everyone ready? Is everyone ready, people? Is everyone ready? And I do not want some irrelevant stuff in the chats. Please and please focus on the session completely, right? Because I would want you guys to be focused from day one itself. I would want you guys to be focused from day one itself. Are you ready with your pen and paper? Everyone. N Avasthi NEET edition. N Avasthi NEET edition, not the JEE edition. So is everyone ready with the pen and paper, people? Everyone in the chats? All right, people. All right, all right. So, without wasting a lot of our time, let's get going. Let's get started with the first chapter of your class 11th chemistry, my dear students. And you all must be knowing the name of the first chapter. That is the mole concept. My dear students, the first chapter which we are going to start with, that is the mole concept. Well, as you all must be knowing, this particular chapter, it forms the foundation of your physical chemistry. This particular chapter, my dear students, it is going to form the foundation of your physical chemistry. Remember, if this particular chapter is strong, your entire physical chemistry will be strong. If there is any problem in this chapter, there will be problems in the entire physical chemistry. So we'll make sure that we are going to make this chapter very, very, very strong, my dear students. All the types of the questions which can be framed, all the types of the questions which can be asked in the chapter mole concept, from the chapter mole concept, I'll be discussing all of them with all of you. Okay? All right? So I do not want any irrelevant stuff in the chats. Please and please focus on the session. Okay? Do not ask me anything in between. If you'll be having certain questions in between, I'll give you time for that as well. But no irrelevant stuff in the chats. Perfect? And if there are some rules in my class, in my plus class, if anyone starts, spamming, talking about nonsense and or, he or she will get blocked at that point itself. Okay? That's something which I keep on doing. Often. All right, guys? So, let me first of all give you the table of the content. Let me first of all tell you what all topics are there in mole concept which we have to discuss. My dear students, we'll be starting with the complete basics. We'll be starting with the complete scratch. Okay? We'll be discussing the basic terminologies first in this chapter. Once we are done with basic terminologies, then we'll be discussing the average atomic mass. Once we are done with average atomic mass, then we'll be talking about the basic mole calculation. After that, we'll be starting with calculation of electrons, protons, neutrons, ions, valence electrons, calculation of charge. calculation of moles of electrons, etc., etc. Then comes your average molar mass of gaseous mixture. Again, one important topic. Then we are going to discuss stoichiometry, right? We are going to discuss stoichiometry in sequential parallel reactions. We are going to discuss the concept of limiting reagent. Once we are done with limiting reagent, then we'll be discussing the percentage yield, percentage purity, mixture analysis, vapor density, percentage composition, empirical molecular formula from combustion. Then comes your POAC, principle of atomic conservation, stereometry, laws of chemical combination, and Dalton's atomic theory. This is going to be the table of content. These are the topics which we have in the mole concept chapter. And my dear students, every topic will be started from the basics and will slowly scale up the level and make it to NEET advanced level for sure. Okay? I would want every one of you to make the notes with me. Okay? I would want every one of you to make the notes with me from today's session itself. Do not rely on the session PDFs and all. I want you guys to make the notes on your own. Perfect? And at the same time, those of you who have not enrolled into the batch yet, you can still enroll into the batch and kickstart your preparation from tomorrow with the Unacademy's team. A lot of students must be thinking that, what about the Telegram group? We did not make the Telegram group yet. Telegram group will be made in the tomorrow session, my dear students. Tomorrow's or day after tomorrow's session. We'll make the Telegram group in the live class itself, in the plus class. I mean, in the app itself. In the next class, we'll be making the Telegram group. Hello, guys. So let's kickstart and let's start with the first topic, my dear students. That is going to be your basic terminologies involved in the chapter mole concept. Basic terminologies involved in the chapter mole concept. Okay. Some of you are asking about how to enroll into the batch. There's a link. There's a link in the description box. You just have to click on that link. Automatically, you can enroll into the batch. And anyways, at the end of the session, I'll tell you in detail how to enroll into the batch. Let's first of all start the today's session. So my dear students, as I told you, first we are going to start with the basic terminologies which are there in the chapter mole concept. And the first basic terminology with which we are going to start this chapter, that is nothing but your atomic mass. So this is the first basic terminology, my dear students, with which I shall be starting this chapter. Atomic mass. Everything in the today's session will be handwritten. Every single thing. So my dear students, what is the simplest definition of atomic mass? How do we define the term atomic mass? Let me tell you, atomic mass is nothing but, it is defined as the mass of, single atom of an element. Atomic mass is defined as the mass of single atom of an element. Now, what does that mean? My dear students, every one of you would be knowing, in the periodic table, there are in total 118 elements. In the periodic table, there are in total 118 elements. Let me select few elements over here. For example, out of 118 elements, let's say I'm selecting nitrogen. Let's say I'm selecting oxygen. Let's say I'm selecting fluorine. These are the three elements which I have selected over here. My dear students, imagine that I have got one atom of nitrogen. Imagine that I have got one atom of oxygen. Imagine that I have got one atom of fluorine. I have got one atom of fluorine as well. So first of all, I have taken three elements. I have selected three elements: nitrogen, oxygen, and fluorine. Imagine that I have got one atom of nitrogen with me. I have got one atom of oxygen with me. I have got one atom of fluorine as well. My dear students, as per the definition, remember the mass of one atom of nitrogen, the mass of one atom of element nitrogen, the mass of one atom of element nitrogen is something I will be calling as the atomic mass of nitrogen. That is something I will be calling as the atomic mass of nitrogen. Similarly, my dear students, as per the definition, the mass of one atom of oxygen, I will be calling as the atomic mass of oxygen. I will be calling as the atomic mass of oxygen. In the similar way, the mass of one atom of fluorine, I will be calling as the atomic mass of fluorine. Atomic mass of fluorine. So first of all, in simplest form, in simplest way, I can define atomic mass as the mass of one atom of an element. For example, if I ask you, what is the atomic mass of sodium? If I ask you, what is the atomic mass of sodium? What does that mean? What am I exactly asking you? I'm asking you, what is the atomic mass of sodium? That means I am asking you, what is the mass of one atom of sodium? For example, I'm asking you, what is the atomic mass of boron? That means I'm asking you, what is the mass of one atom of boron? Atomic mass of carbon. I'm asking you, what is the mass of one atom of carbon? As simple as that. Okay? So in short, the mass of one atom of an element is what you call as atomic mass. Now, my dear students, let's get into the details of this atomic mass. Let's get into the details of the term atomic mass. And how do we get into the details of atomic mass? Let's try to understand. My dear students, for example, let's say I have got an object over here. This object can be anything. Okay, this object can be anything. Similarly, I've got one more object which is comparatively bigger in size. And similarly, I've got one more object which is comparatively bigger in size. So how many objects I've taken over here? How many objects I've taken over here? I can say I've taken 3 objects. Okay? Let's assume the weight of the first object is 5 kilograms. Let's assume the weight of the second object is 10 kilograms. And let's assume the weight of the third object is 20 kilograms. So first of all, I have taken 3 objects. The weight of the first object is 5 kg. The weight of the second object is 10 kg. And the weight of the third object is 20 kg. Now, my dear students, can I just do one thing? Instead of 5 kg, can I write it as 5 multiplied by 1 kg? I can do that. Because you know 5 into 1 kg becomes equal to 5 kg. Similarly, 10 multiplied by 1 kg becomes equal to what? 10 kg. Similarly, 20 multiplied by 1 kg becomes equal to what? 20 kg. Perfect. So if you look carefully, why did I break 5 kg as 5 into 1 kg? Why did I break 10 kg as 10 into 1 kg? Why did I break 20 kg as 20 into 1 kg? What is the logic? What is the reason? My dear students, just to make you understand one thing. What is that? I can say this particular object is 5 times heavier than 1 kilogram. I can say this particular object is 10 times heavier than 1 kilogram. I can say this particular object is 20 times heavier than 1 kilogram. Right? My dear students, my weight is 85 kilograms. What does that mean? That means I am 85 times heavier than what? I am 85 times heavier than 1 kilogram. Correct? So can I say I am comparing the weights of different objects? Can I say I am comparing weights of different objects with what? With 1 kg. I can simply say I am comparing weights of different objects with what? With 1 kg. So my dear students, this 1 kg with which I am comparing weights of different objects, this 1 kg becomes my reference. This 1 kg becomes my reference. This 1 kg becomes my standard. This 1 kg becomes my standard with which I'm comparing the weights of different objects. Right? Okay. Now, my dear students, you know in chemistry, we deal with atoms, we deal with molecules, we deal with ions. Don't you think in chemistry, we should have a standard, we should have a reference like this 1 kg so that we can compare the masses of different atoms or molecules with that standard? So first of all, again, my dear students, this 1 kg is our standard here. This 1 kg is our reference here with which I'm comparing the weights of different objects. Now, in chemistry, we need a standard like 1 kg. We need a standard like 1 kg, with which we are going to compare the masses of different atoms, the masses of different molecules. Now, what is that standard in chemistry? What is that reference in chemistry with which we are going to compare the masses of different atoms, with which we are going to compare the mass of different molecules? What is that standard? Let's get to know that. Let's get to know that. My dear students, in chemistry, we are going to make that standard. In chemistry, we are going to make that standard. And let me tell you, in order to make that standard in chemistry, we are going to take the carbon-12 atom. In order to make that standard in chemistry, we are going to take which atom? We are going to take carbon-12 atom. Let's assume this is your carbon-12 atom. Let's assume this is your carbon-12 atom. My dear students, in order to make the standard in chemistry, which atom I took? I took carbon-12 atom. Now this carbon-12 atom, my dear students, I am going to divide into 12 equal parts. This carbon-12 atom I divided into how many parts? This carbon-12 atom I divided into 12 equal parts. After dividing this carbon-12 atom into 12 equal parts, if I take the small part, people, if I take the small part over here, can I say the mass of this small part is going to be nothing but it will be 1/12 of the mass of carbon-12 atom? It will be 1/12 of the mass of carbon-12 atom. So first of all, what am I doing? I am going to make a standard. I am going to make a reference in chemistry with which I am going to compare the masses of different atoms or molecules. And in order to make that standard, I took a carbon-12 atom. I divided carbon-12 atom into 12 equal parts. After dividing carbon-12 atom into 12 equal parts, I took just one part of it. And the mass of this shaded part, the mass of this one part, the mass of this shaded part is nothing but it is 1/12 of mass of carbon-12 atom. And let me tell you, my dear students, let me tell you, this 1/12 of mass of carbon-12 atom, from today, you are going to call it as 1 AMU, or you will be calling it as 1 U, or you will be calling it as 1 D. This 1/12 of mass of carbon-12 atom, you'll be calling it either as 1 AMU, or you'll be calling it as 1 U, or you'll be calling it as 1 D. And let me tell you, first of all, this AMU stands for atomic mass unit. It stands for atomic mass unit. My dear students, this U, it stands for unified mass. It stands for unified mass. And this D over here, it stands for what? It stands for Dalton. This D stands for Dalton. Okay? Now, my dear students, let me tell you one more thing. There was a technique used, and that technique was called as mass spectrometry. There was a technique used. That technique was called as mass spectrometry. And with the help of mass spectrometry, let me tell you, the mass of entire carbon-12 atom was calculated. There was a technique used called as mass spectrometry. And with the help of mass spectrometry, the mass of entire carbon-12 atom was calculated. And let me tell you, the mass of entire carbon-12 atom was found out to be 1.99 into 10 raised power minus 23 grams. So by using the technique called as mass spectrometry, the mass of entire carbon-12 atom was calculated. And let me tell you, the mass of entire carbon-12 atom was found out to be 1.99 into 10 raised power minus 23 grams. Now, my dear students, just tell me one thing. Just tell me one thing. Do we know the mass of this entire carbon-12 atom? Yes, we know the mass of entire carbon-12 atom. How much is that? 1.99 into 10 raised power minus 23 grams. Now, can we calculate the mass of this shaded part in grams as well? This is the mass of entire carbon-12 atom. If I divide this term by number 12, I will be getting the mass of this shaded part over here. Right? So, what am I going to do now? What is this particular term? I'll say this is the mass of entire carbon-12 atom. This is the mass of one carbon-12 atom. Now, if I divide this term with the number 12, so let me do that. 1.99 into 10 raised power minus 23 grams. I'm dividing it with the number 12. When you divide it with the number 12, you get the value exactly as 1.66 into 10 raised power minus 24 grams. When you divide this particular number with 12, you get the value exactly as 1.66 into 10 raised power minus 24 grams. So if I ask you, my dear students, this 1.66 into 10 raised power minus 24 grams, is it the mass of entire carbon-12 atom? You will say no, this is not the mass of entire carbon-12 atom. If I ask you, is it the mass of this shaded part? You will say yes, it is the mass of the shaded part in grams. Okay? And let me tell you, people, let me tell you, remember when 1 is divided with Avogadro's number. I hope every one of you knows Avogadro's number. Avogadro's number represented by Na is nothing but 6.022 into 10 raised power 23. Correct? Remember, when 1 is divided with Avogadro's number, you get the value exactly as 1.66 into 10 raised power minus 24 grams. You can check that at the end. When 1 is divided with Avogadro's number, you get the value exactly as 1.66 into 10 raised power minus 24 grams. There's a guy spamming. Let me block him just a second. Blocked. Okay. So first of all, people, if I quickly summarize the things which I talked about till now, as I told you, we are going to make a standard in chemistry. We are going to make a reference in chemistry with which we are going to compare the masses of different atoms or molecules. And in order to make that standard, I took the carbon-12 atom. I divided carbon-12 atom into 12 equal parts. After dividing carbon-12 atom into 12 equal parts, I just took the small part. And the mass of this small part is nothing but 1 by 12th of mass of carbon-12 atom, which is what I'll be calling as 1 AMU or 1 U or 1 D. AMU stands for atomic mass unit, U stands for unified mass, D stands for Dalton. By using the technique called as mass spectrometry, the mass of entire carbon-12 atom was calculated. How much? This much. And if you divide this term by the number 12, you get the value exactly as 1.66 into 10 raised power minus 24 grams. And this 1.66 into 10 raised power minus 24 grams can be written as 1 divided by Na grams. Okay. Now, people, if I quickly summarize every single thing, I can say 1 AMU is nothing but, it is 1 U. 1 U is nothing but 1 D. How did we define this 1 D? It is defined as 1 by 12th of the mass of carbon-12 atom. 1 by 12th of the mass of carbon-12 atom. And my dear students, its value came out to be how much? Its value came out to be 1.66 into 10 raised power minus 24 grams. And let me tell you, in terms of Avogadro's number, you are going to write it as 1 divided by Na grams. Now, tell me once in the chats if this particular statement is clear to every one of you. Let me know quickly in the chats if this particular statement is clear to every one of you. Let me know quickly in the chats with some thumbs ups, people. Everyone. Let me know quickly in the chats if this particular concept is clear to every one of you. Just tell me yes or no in the chats. I'll take all your questions at the end of the session. Just say yes or no in the chats. If every single thing is clear, I want everyone to say it. Everyone, people. I'll share the PDF of this session as well. I'll share the PDF of the today's session as well on my personal Telegram. The name of the Telegram channel is Wassim Bhat Chemistry Official. Wassim Bhat Chemistry Official is the name of the Telegram channel on which I shall be sharing the PDF of the today's session, handwritten PDF of the today's session. Okay? If you are not the part of the Telegram channel, be the part of the Telegram channel as well. Okay? Chalo guys, let's move on. Let's move on. Let's move on. Now, my dear students, let's try to understand few points. Let's try to understand few points. What if I write a term? What if I write a term, atomic mass of nitrogen? What if I write a term, atomic mass of nitrogen? What does it mean? Atomic mass of nitrogen, what does it mean? Atomic mass of nitrogen means nothing. It just means the mass of one atom of nitrogen. It just means the mass of one atom of nitrogen. And let me tell you, my dear students, every one of you will be already knowing. What is the mass of one atom of nitrogen? It is nothing but 14 AMU. It is nothing but 14 AMU. Now, can I break this 14 AMU as 14 multiplied by 1 AMU? Yes, I can do that. I can break 14 AMU as 14 into 1 AMU. Now, people, I can write 14 as such. Instead of 1 AMU, can I write 1 by 12th of mass of carbon-12 atom? I can do that. Now tell me one more thing. Instead of 1 AMU, can I write 1.66 into 10 raised power minus 24 grams? Absolutely, I can do that. Instead of same 1 AMU, can I write 1 divided by Na grams? Absolutely, I can do that. Now, people, what is the meaning of all these terms which I wrote over here? First of all, this is the mass of one atom of nitrogen. This is the mass of one atom of nitrogen. I can say one atom of nitrogen is 14 times heavier than 1 AMU. I can say one atom of nitrogen is 14 times heavier than what? Heavier than 1 AMU. I can say one atom of nitrogen is 14 times heavier than 1 by 12th of mass of carbon-12 atom. One atom of nitrogen is 14 times heavier than 1 by 12th of the mass of carbon-12 atom. Can I say this is the mass of one nitrogen atom in grams? Yes. Even I would say this is the mass of one nitrogen atom in what? In grams. Even this is the mass of one nitrogen atom, but in AMU. Am I clear? Am I clear, people? Again, one more statement I'm writing. For example, just to make you understand, I'm writing atomic mass of oxygen. Atomic mass of oxygen. What does that mean? That means I'm talking about the mass of one atom of oxygen. That means I'm talking about the mass of one atom of oxygen. And how much that is? Every one of you should be familiar with it. How much is that? That is nothing but 16 AMU. That is nothing but 16 AMU. Now, people, can I just do one thing? Can I write 16 multiplied by 1 AMU? Absolutely. Right? Instead of 1 AMU, can I write 1 by 12th of mass of carbon-12 atom? Absolutely. Instead of 1 AMU, can I write 1.66 into 10 raised power minus 24 grams? Absolutely, I can do that. Instead of 1 AMU, can I write 1 divided by Na grams? Absolutely, I can do that as well. Okay. So if you look carefully, what is this term? This is the mass of one oxygen atom in AMU. I would say one oxygen atom is 16 times heavier than 1 AMU. I would say one oxygen atom is 16 times heavier than 1 by 12th of mass of carbon-12 atom. Right? I can say this is the mass of one oxygen atom in grams. I would say even this is the mass of one oxygen atom in grams. Tell me once in the chats if every single thing is clear. Everyone, people. Everyone, people. Everyone in the chats. Yes, you can still enroll into the batch. Batch has started today. There's a link in the description box. You can start. You can click on the link, enroll in the batch today also, right? And from tomorrow, you can join the live session. Am I clear, everyone? Which batch? The Phoenix 2.0 batch, whose first class is happening right now. From tomorrow, classes won't happen on YouTube. They'll happen in the app itself, Unacademy app. All right. Now, guys, after talking about all of this stuff in detail, can I say something like this? Just tell me whether it's correct or not. If I say atomic mass, of an element, gives an idea about how many times an atom of an element is heavier than 1 AMU. Can I say something like this? People? Pretty much simple. See, you got to know one atom of nitrogen is 14 times heavier than 1 AMU. One atom of oxygen is 16 times heavier than 1 AMU. Similarly, one atom of sodium will be 23 times heavier than 1 AMU. Right? So I would say atomic mass is just giving me an idea about how many times an atom of an element is heavier than 1 AMU. Pretty much simple. And if this is understood, let me tell you one more thing, people. What is that? Remember. What is that? Remember. For example, I am taking an element oxygen over here. Now, my dear students, remember, for oxygen, I'm going to write 3 terminologies. The first term I'm going to write, that is 16 AMU. The second term I'm going to write, that is just 16, no units. The third term I'm going to write, that is 16 multiplied by 1 AMU, and instead of that 1 AMU, I'm writing 1.66 into 10 raised power minus 24 grams. So with respect to oxygen, I wrote 3 terminologies. 16 AMU, 16 into 1.66 into 10 raised power minus 24 grams. Let me tell you, people, this 16 AMU is something I call as the atomic mass of oxygen. Just this 16 without the units. I call this as the relative atomic mass of oxygen. And this particular term, we call this as the actual mass of oxygen. Remember these 3 terminologies. For example, let's say I have got an element X. Let's say I have got a general element X. Now, with respect to X, the first term I'm writing, that is M AMU. The second term is just M. Third term is M multiplied by 1.66 into 10 raised power minus 24 grams. Can you tell me the names of all these terms? The first term, my dear students, which you can see over here, this is the atomic mass of an element, X. This is what you call as the relative atomic mass of X. And this is what you call as the actual mass of the X. The actual mass of the element X. I believe all these 3 points are very much clear to you. And if all these 3 points are clear to you, let me give you one question so that you can understand the concept in a better way. My dear students, the question is pretty much simple. I'm writing a question. Calculate the mass of what? Calculate the mass of 10 sodium atoms. Calculate the mass of 10 sodium atoms. Number 1, in AMU. Number 2, in grams. Number 3, in kilograms. This is a simple question which I wrote over here. Calculate the mass of 10 sodium atoms. 10 sodium atoms. First, in AMU. Second, in grams. Third, in kilograms. My dear students, the question is pretty much simple. Since they are asking us what is the mass of 10 sodium atoms, I do not know the mass of 10 sodium atoms, but I know the mass of 1 sodium atom. I do not know the mass of 10 sodium atoms, but I know the mass of 1 sodium atom. And you know, the mass of 1 atom of sodium, the mass of 1 atom of sodium, which is what we call as atomic mass of sodium, is nothing but, that is 23 AMU. That is 23 AMU. In grams, it would be 23 multiplied by 1.66 into 10 raised power minus 24 grams. Right? Perfect. We do not know the mass of 10 sodium atoms. We just know the mass of 1 sodium atom. In AMU, it's this much. In grams, it is this much. Now, people, it's pretty much simple. If the mass of 1 atom of sodium is this much, mass of 2 atoms will be multiplied by 2. Mass of 3 atoms multiplied by 3. Mass of 4 atoms multiplied by 4. Mass of 10 atoms. Mass of 10 atoms of sodium would be how much? 23 into 10 will be 230 AMU. Similarly, in grams, it will be 23 into 10 will be 230 into 1.66 into 10 raised power minus 24 grams. I would say this is the mass of 10 sodium atoms in AMU. This is the mass of 10 sodium atoms in grams. Similarly, you can calculate the mass of 10 sodium atoms in kilograms as well. Since you got the unit in grams, now convert it in kilograms. How? Divide this term with 1000. Divide this particular term with 1000. You'll be getting the answer in kilograms. As simple as that. Am I clear, people? Am I clear? Gram atomic mass is something different. That we'll be discussing later on. Okay? Do not intermix with the terms. Whatever I'm telling you, just remember that. Do not use your brain. Okay? Do not use your brain. Is it clear, guys? Everyone in the chats? Is it clear? Everyone in the chats? Perfect. Now, guys, one more. This was a simple conceptual question, basic question, one-liner question, right? These questions won't be asked in NEET. I'm just building your basics right now. Whatever question I solve, this is never going to be asked in NEET. You know that, right? It is just I'm building your concepts, basically. Building your basics, making your foundation strong. Okay? Now, guys, for example, what if the question comes like this? What if the question comes like this? If one AMU is defined as, if one AMU is defined as 1/6 of the mass of carbon-12 atom, if one AMU is defined as 1/6 of the mass of carbon-12 atom, calculate the atomic mass of oxygen. Calculate the atomic mass of oxygen as per the new scale. Calculate the atomic mass of oxygen as per the new scale. Calculate the atomic mass of oxygen as per the new scale. Now, let's try to understand. Let's try to understand what the question is all about. Okay? Try to understand, people. My dear students, whenever you see this sort of a question, how do you deal with this? How do you deal with this? Try to understand. First of all, as every one of you knows, how do we define one AMU? How do we define one AMU? We define one AMU as 1/12 of the mass of carbon-12 atom. This is how we define one AMU. This is how we define 1 AMU. Okay? Now, as per the question, how 1 AMU is defined? As per the question, 1 AMU is defined as 1/6 of the mass of carbon-12 atom. Okay? As per us, how do we define 1 AMU? We define 1 AMU as 1/12 of mass of carbon-12 atom. As per the question, they are defining 1 AMU as 1/6 of mass of carbon-12 atom. And just to differentiate, I'm calling this as AMU dash. Just to differentiate, I'm calling this as AMU dash. My dear students, this is the scale. This is the scale which we have chosen. I call this as conventional scale, or you can call it as the old scale. This was the old scale, right? This is the new scale that is given to me in the question. This is the new scale that is given to me in the question. And as per the question is concerned, what are we supposed to calculate? As per the question is concerned, what are we supposed to calculate? The atomic mass of oxygen as per new scale. So we have to calculate atomic mass of oxygen, not in terms of AMU. We have to calculate atomic mass of oxygen in AMU dash as per the new scale. Now, how do we do it? My dear students, the first thing which you'll be always doing, what is that? Just divide these two equations. Just divide these two equations. When you divide these two equations, what do you get? You get 1 AMU divided by 1 AMU divided by 1 AMU dash. 1 AMU divided by 1 AMU dash is equal to this term gets cancelled. In the numerator, you got 1/12. In the denominator, you got 1/6, right? So this can be written as 1/12 into 6. So the value is coming out to be 1/2. The value is coming out to be 1/2. So my dear students, we got to know 1 AMU divided by 1 AMU dash is equal to 1/2. So I can say 1 AMU is nothing but take this AMU dash here. So it's going to be 1 AMU dash divided by 2. 1 AMU dash divided by 2. So I got the relation between AMU and AMU dash. I got the relation between AMU and AMU dash. So first of all, I wrote the two scales. After writing the two scales, I divided these two equations. I got the relation between AMU and AMU dash. Now people, tell me just one thing. What are we supposed to calculate? Atomic mass of oxygen. Do we know the atomic mass of oxygen already? Atomic mass of oxygen as per our scale, used to be how much? It used to be 16 AMU. Atomic mass of oxygen as per our scale used to be how much? Atomic mass of oxygen as per our scale used to be how much? 16 AMU. But we do not need the answer in AMU. We need the answer in AMU dash. So what am I doing? I'll be writing it as 16 multiplied by 1 AMU. 16 AMU, I'm writing as 16 multiplied by 1 AMU. And my dear students, I already know 1 AMU is equal to 1 AMU dash by 2. So instead of 1 AMU, I'm writing 1 AMU dash divided by 2. So this is 2, 1, this is 2, 8. So it comes out to be 8 into 1. That means 8 AMU dash. So this is the new atomic mass of oxygen as per the new scale. Yes? Understood, people? I was supposed to calculate the atomic mass of oxygen as per new scale. So this is the atomic mass of oxygen as per the new scale. Did you understand the process of solving? Did you understand the process of solving this sort of equation? Perfect. Let me give you one more question. And you are going to solve this on your own right now. I'm writing a simple question, the similar question, and you guys are going to give it a try. If 1U, since AMU is also written as U, right? AMU is what you call as U also. So instead of AMU, you can write U also. If 1U is defined as, if 1U is defined as 1/24th of the mass of carbon-12 atom, 1/24th of the mass of carbon-12 atom, then calculate Then calculate atomic mass of nitrogen as per the new scale. Can you give this question a try? Everyone. Can you give this question a try, people? Every one of you? Sir, how good is your handwriting? Is it that good? I know it's very good. Quickly give this question a try, people. The way I solved the question earlier, you are going to solve the same question like this. Everyone. Everyone in the chats, quick, quick, quick. Someone is saying 7 AMU dash, someone is saying 28. So someone is saying 46. All right, let me give this a try. Let me try it out. My dear students, you know, how do we define 1 AMU? Or I can call it as U also. How do I define 1 U? 1 U we define as 1 by 12th of mass of carbon-12 atom. 1 by 12th of mass of carbon-12 atom. And as per the question, how this U is defined, I'm calling it as U dash. It is defined as 1 by 24th of the mass of carbon-12 atom. 1 by 24th of the mass of carbon-12 atom. Now, my dear students, when I divide these two equations, if I divide these two equations, I'll get U divided by U dash. U divided by U dash. U divided by U dash will be equal. This term cancels out. In the numerator, we got 1 by 12. In the denominator, we got 1 by 24. So this can be written as 1 by 12 into 24. The value comes out to be 2. So people, you got U divided by U dash is equal to 2. So I can say U is equal to 2 times U dash. U is equal to 2 times U dash. Just cross multiply. I got to know U is equal to 2 times U dash. Since I got the relation between U and U dash. Now, as per the question, what was I supposed to calculate? I was supposed to calculate the atomic mass of nitrogen as per the new scale. I can say atomic mass of nitrogen as per our scale is how much? That is 14U. Atomic mass of nitrogen as per our scale is how much? 14U. But do I need the answer in U or U dash? I need the answer in U dash. So I can write it as 14. Instead of U, I'm writing 2 times U dash. So the value comes out to be 28 U dash. So my dear students, 28 U dash is the atomic mass of nitrogen as per the new scale. I believe this particular concept is clear to every one of you. Okay? So with this, we are done with the term atomic mass, right? I believe this particular concept is very much clear to you. Let me do the quick recap of the things which we discussed till now. Just listen to me. My dear students, we defined atomic mass in the beginning as the mass of one atom of an element. The mass of one atom of an element. I took 3 elements in the beginning. Nitrogen, oxygen, fluorine. I told you the mass of one atom of nitrogen is called as atomic mass of nitrogen. The mass of one atom of oxygen is called as atomic mass of oxygen. The mass of one atom of fluorine is called as atomic mass of fluorine. Then, in order to have the better understanding of atomic mass, I took three objects. The weight of first object was 5 kg. The weight of second object was 10 kg. The weight of third object was 20 kg. I divided 5 kg as 5 into 1 kg. 10 kg as 10 into 1 kg. 20 kg as 20 into 1 kg. Why? Because I had to make you understand one thing. What is that? The first object was 5 times heavier than 1 AMU. Sorry. The first object was 5 times heavier than 1 kg. The second object was 10 times heavier than 1 kg. The third object was 20 times heavier than 1 kg. So can I say I was comparing the weights of different objects with 1 kg? So that 1 kg was our standard. That 1 kg was our reference with which I was comparing the weights of different objects. Now, in chemistry, we needed a standard, we needed a reference like 1 kg so that we could compare the masses of different atoms or molecules with that standard. And my dear students, in order to make that standard in chemistry, I took carbon-12 atom. I divided carbon-12 atom into 12 equal parts. I took a small part of it. I told you its mass is nothing but 1/12th of mass of carbon-12 atom, which I called as 1 AMU or 1 U or 1 D. AMU was called as atomic mass unit. U was called as unified mass. D was called as Dalton. By using the technique called as mass spectrometry, the mass of entire carbon-12 atom was calculated. How much? 1.99 into 10 raised power minus 23 grams. When you divide that with the number 12, you get the value as 1.66 into 10 raised power minus 24 grams. And in terms of Avogadro's number, you call it as 1 divided by Na gram. Therefore, I generalize the statement. 1 AMU is equal to 1 U is equal to 1 D is equal to 1/12th of mass of carbon-12 atom is equal to 1.66 into 10 raised power minus 24 grams is equal to 1 divided by. Then I wrote a statement. Atomic mass of nitrogen. What is that? That is mass of one atom of nitrogen is equal to 14 AMU. 14 AMU I broke it as 14 into 1 AMU. Then I wrote it as 14 into 1/12th of mass of carbon-12 atom. Then I wrote it as 14 into 1.66 into 10 raised power minus 24 grams. Then I wrote it as 14 into 1 by Na gram. Right? Correct? Therefore, after that, I told you atomic mass gives an idea about how many times an atom of an element is heavier than 1 AMU. Then I told you, for an element, you can write three things. For example, if I select oxygen, I can write 16 AMU. I can write 16 into 1.66 into 10 raised power minus 24 grams. The first term I call as atomic mass. The second I call as relative to atomic mass. And the third I call as the actual mass. Right? Then people, we solved some questions like this on changing the scale. How to calculate the new atomic mass. On changing the scale. How to calculate the new atomic mass. Right? I told you, you just have to make two equations, divide the two equations, get the relation between U and U dash, then you can easily calculate the atomic mass of an element as per the new scale. So tell me once in the chats if every single thing is clear till here or not. Tell me in the chats if every single thing is clear or not. Everything in the chats. So guys, this was the first session of our Phoenix 2.0 batch, whose first live class I took today on YouTube. And from tomorrow, all the other classes will happen on the app itself. Okay? Or maybe the first class of every subject will happen on YouTube. And second class will directly happen in the app itself. Right? All those students who did not enroll into the batch yet, okay, who are still thinking what this Phoenix 2.0 batch is all about, let me quickly give you the idea of what this Phoenix 2.0 batch is all about. This Phoenix 2.0 batch, it is a batch which is dedicated for NEET 2027 aspirants. And my dear students, this batch is started today. Well, today is the first class, as I told you. Entire syllabus in the batch, entire 11th plus 12th syllabus of PCB will be completed by December end or maximum by 15th of January, right? All the chapters will be start from the basics, will be start from the scratch, and will be taken to the advanced level, NEET advanced level. You will be providing you the study material from our side. You'll be getting the study material, advanced study material. You'll be getting DPPs also, daily practice problems. You'll be getting the mock tests after every 14 to 21 days. You'll be writing the mock test. Okay, whatever portions we are going to complete in 14 to 21 days. After every 14 to 21 days, you'll be writing the test of that portion. And that test is again going to be level up test. On an average, there'll be 3 live classes every day. By any means, if you are not able to join the live classes, you'll be having the access to recordings as well. There'll be one-on-one mentorships. Basically, once you write the test, we'll be analyzing your scores after the test, and we'll keep on having one-on-one mentorship sessions with you, wherein we'll let you know where your weaknesses are, whether the problem is in calculation, whether the problem is in concept, how you can rectify those problems and convert them into your strengths, right? You'll be under my mentorship for one complete year, my dear students, and you'll be having the access to all the Unacademy batches as well. What is meant by that? See, in order to be the part of this batch, you just have to take either plus subscription of Unacademy or Iconic subscription. You'll have to take plus subscription of Unacademy or Iconic subscription. And my dear students, if you take the plus subscription, the cost of the plus subscription is 4699. And if you take the plus subscription, you will be having the access to all these batches, right? This is my batch in English language. This is my one more batch or in English language. This is Seep Ma'am's batch in English. One more batch by Garima Ma'am. One more batch by AKM Sir, Acid Sir. Okay? So, at just 4699, you are having the access to all these batches with all the things that I told. Okay? In just 4699. So, be the part of the batch as soon as possible if you're not enrolled, right? You'll be having the access to all these batches. You can check all these classes of all these batches, and all these batches are basically for NEET 2027 students. Okay? Whether you are writing it for the first time, second time, etc. And people, at the same time, how do we get enrolled into the batch? Before talking about that, these are the top-notch educators of the country, right? You'll be having the access to all their batches, all their classes for the NEET 2027. There'll be live doubt-solving sessions every day as well, right? Apart from the live classes, there'll be 3 doubt-solving sessions, one for physics, one for chemistry, one for biology, every single day. Okay? Access to all the batches of Unacademy, as well as the upcoming batches. You know, once we complete the syllabus here, then we are going to start the crash course batches. Perfect? You do not have to pay anything in those crash course batches. They'll be free for you. Interactive live classes, you know, right? Test series is provided. Live tests and quizzes, digital notes and study material is provided. Perfect? And at the same time, now you know your NEET is going to be of the CBT format, computer-based test. So you can get the offline CBT as well. If you want a separate test series, apart from the batch tests will happen after every 14 to 21 days. Apart from that, if you want to take a separate test series, you can take that. The offline CBT mode, you have to take this separately. How exactly? I'll tell you how. Okay. And my dear students, basically in this offline computer-based test series, what is there? There are 28 tests in total in this test series, in the separate test series, which you can see over here. Okay, there are 28 tests in total. And my dear students, you can, if you are taking the offline CBT, then you will have to write those tests in your nearest Unacademy centers. Well, there is one more option of taking the online CBT as well. You can write those 28 tests at home. You just need a tab or a laptop or a computer, whatever you have. Perfect. That is completely AI monitored. You cannot do any sort of cheating during the test. Perfect. It's completely your wish, whether you want to go for offline CBT or online CBT. And people, at the same time, how do we get enrolled into the batch? Well, I can say there's a link here. Which is pinned in the chats. The link is pinned in the chats. Or, my dear students, there would be the link in the description box of this video as well. You just have to click on the link. After clicking on the link, my dear students, you will be having 2 options. Either you can take plus subscription or you can take Iconic subscription. What is the difference between plus and Iconic? If you are taking plus subscription, you'll be getting all the features which I told you. But In Plus subscription, you get the study material in the form of PDF. But if you take the Iconic subscription, you get the study material in the form of booklets, and those booklets are delivered to your house, right? So, for example, you are taking the Plus. If you are taking Plus, you have to click on 12-month subscription. You can use the code WASSIM in order to be under my mentorship for 1 complete year. Click on continue. After click on continue, here you have got the option to take either offline CBT or online CBT. You can add here if you want to take the CBT and click on continue. After clicking on continue, you can put your mobile number on which you'll be getting the OTP and everything. And eventually, my dear students, you'll be getting enrolled. You'll be having the access to all the features which I told you till now in this Phoenix 2.0, right? So this was the first session. And with this, my dear students, we are going to end the today's session. But one thing I would want genuinely in the comment section, how did you like the session? Okay. That is something which I would want in the comment section from every one of you. That is something which keeps us driving all the time. Okay. That is something which keeps us driving all the time. Someone is asking, why did we take carbon? You'll get its answer in the next class. Till then, think about it. Okay? Not in the chats, guys, in the comment section. In the comment section. Okay? I would want every one of you to comment in the comment section how genuinely, a genuine, honest comment I would want about this class. A genuine, honest comment. Not in the chats, in the comment section once the video ends. Okay? Chalo. With this, I'll be taking a leave. I'll see you in my next session, my dear students. Right? And weekly, I'll be taking 4 sessions. Every week, I'll be taking 4 sessions in. Right? I won't be taking the classes for all the 6 days. No, I'll be just taking 4 sessions in a week. The duration of my class will be 1.5 hours. So maybe I can extend it to 1 hour 45 minutes. Okay? Chalo. Taking a leave with this. If you have not enrolled in the batch yet, do get enrolled as soon as possible. And I will be looking at your comments, guys, once the video ends. See you guys. Take care.